Hey guys, welcome back. Today we're looking at 5.6 part 2. So we're wrapping up our unit on exponentials and logs, which is exciting. Today we're going to need our calculators. You're going to have to use a calculator because we're going to be calculating these logs. Well, technically you don't. But if you do, then you can take one out because it might make it more concrete to you what we're trying to do here. All right, so this time it's a little different, right? We're not starting off with logs and ln's and stuff like that in our equation. So this tells us we got to solve it a little bit more different, or a little bit differently than we were doing in the last class. All right, so remember this property, right? We said that if we have log base a of some number, I don't know, we said x squared, right? We said that this property here, anytime we have a log, right, we can take exponents and drop them down in front. So that property we kind of alluded to earlier, this is pretty huge because if we have a log, then we can get into our exponent and bring it down, and we can treat it like any other multiplication we have algebraically, right? So the problem here is we don't have a log. But the good thing is we know that in algebra we can do, as long as we do the same thing on the left side and right side, we still balance the equation. So the normal way we do it is ln. It works with log as well, but for some reason most people just will use the ln instead of doing a log. So what we're going to do here is, first step is we're going to log, or ln, excuse me, both sides. Okay, so we're going to rewrite this as ln 2 to the x equals ln 5. All right, so that's the crucial thing here. We don't have an ln, we don't have a log, so we're going to do that because we want to get to this variable that's in the exponent. Okay, step 2. We're going to apply the property, right? We take any exponents we have, drop down in front. So we have x times ln 2 equals ln 5. Okay, and then the last step here is we're going to solve. So we want the x to be by itself. This is a multiplication, so we're just going to divide by ln 2. So x equals, and this is the reason why I said you can use a calculator or not use a calculator, because this is an acceptable answer, right? But to make it more concrete, ln 5 is a value, and ln 2 is also a value. So if we go to our calculator here, whoops, ln 5 divided by ln 2, let's go to our calculator. So we're going to do ln 5, close the parentheses, right? We don't want to ln anything other than the 5, divided by ln 2 is equal to, and let's round to the nearest thousandth, 2.322. So you could also say that this is approximately 2.322, right? It's approximate because we rounded, that's why we have the squiggly equal sign. Okay, so this is a huge thing. We can take our ln, both sides, in order to get from our variable in the exponent, drop it down in front. Okay, this one too, rather than make it complex, because, right, we'd ln both sides at this point and say ln 8 times 3 to the x. We'd have to do an expansion there, ln 8 times plus ln 3 to the x equals, instead of doing that, let's clean this up a little so we can just ln the 3x, right, or 3 to the x. So the first step here is we're going to clean it up by dividing out the 8. Get that out of the way so there's no like weirdness going on the left-hand side. So we have 3 to the x equals 5 over 8. So step 1, clean it up, right? We only want to ln the things that we need to ln. So if we can move anything around algebraically, do that first. Okay, at this point, we're going to apply the second thing, right? We want to get to the x now, right? Let's get to the x. We're going to ln both sides. And keep in mind here, I'll put parentheses up because we're taking the ln of the whole right side, right? So we're taking the ln of that fraction. All right, so ln both sides, just like we did in the last example. What that allows us to do, right? Step 3, drop any exponents. X ln 3 equals ln 5/8. Okay, and then we just got to divide by ln 3 to get to our x. And this looks like a mess, right, on the right-hand side. ln parentheses, right? The parentheses are important to make sure that anyone who's reading this understands that we're taking the ln of the fraction 5/8, right? We're not doing ln 5 divided by 8. It can get confusing if we don't have those grouping symbols in there. Over ln 3. Okay, and then this would be acceptable. But those of you who like to do calculations to get a number, an idea of what value this is, whoops. I'm going to do ln 5 divided by 8, close the parentheses, divided by ln 3. It's approximately negative 428. Negative 428. All right, either one is acceptable. And then on to the last one. Let's use orange or gold or whatever you think that is. Okay, so there's nothing we can simplify, right? There's no additions or subtractions, but what we do have is we have x's in both of our exponents. So it's going to be a little bit more complex, but the foundation of it is the same, right? The algebra of it is going to be a little bit more complicated, and you'll see how that works in a little bit. So there's nothing left to clean up, so let's just go ahead and ln, right? So we're going to do ln. I put parentheses on the exponents just to make sure that we understand that's a whole exponent there. Okay, so step 2 is we can take those exponents, drop them in front. All right, so here's the part where it's going to get complicated. Remember, ln 5 and ln 3 are just numbers, right? We don't have to know their exact value now, but we can treat them like any other number. So what we're going to do here is, oops, I forgot to write step 2. Drop exponent. Okay, step 3. We're going to distribute here, right? Because we could divide the ln 5, we could divide the ln 3, but we'd still be in a weird situation because we have x's on both sides still, and we have multiplications there. It's going to be like a clump of things that's not very nice to deal with right now. So we're going to distribute. I'm going to change colors here again. Let's use a color we don't usually use. Let's use red. I guess we're going to distribute. Oh, hey, that's not red. And distribute here. Distribute there. So we have x ln 5 minus 2 ln 5, and then we have x ln 3, and then we have 2 ln 3, and now we're just going to be using algebra. I know this looks weird because we have all those ln's and numbers there, but we really have 4 terms. We have this, 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 and this. So what we're going to do is we're going to get the x's to one side. So it doesn't really matter. Let's do this one. Let's subtract this one. And then let's move them both at the same time. So I'm going to add the 2 ln 5 to both sides. And what that does is it moves the x to the left, and it moves this thing that doesn't have an x in it to the right. So we're going to do, and remember, these are not divisions, right? These are just showing the 4 terms. Let's use a different color here, clean it up. Okay, so what we have on the left side is x ln 5 minus x ln 3, right? Those are the things that's left over. And then we have this thing here. So on the left side, we have 2 ln 3 plus 2 ln 5. Some of you might really want to combine them, right? But because we don't have the same ln's and the x, because we don't have the same ln's here, we can't just combine them. We can't just subtract them and add them. So be careful there. But now what we can do, applying some more algebra, because the left side has 2 terms and they both they both have x's in them, we can factor that x out. So the step is important. Factor out x. Actually, maybe this should be step 5. Step 5, factor out the x. And then this side says, this step here is move x to one side, right? Everything not x should be on the other side. Okay, again, because we have x's in both of these things, we can factor the x out. And then we have ln 5 minus ln 3. Okay, and guess what? To get the x by itself, it's x times this whole thing, so we just got to divide. Because that cancels with that now. So x is equal to this whole thing here. Right, which we said is acceptable. We can stop there. Or what we can do is we can do our calculator. So let's go ahead and calculate 2 ln 3, 2 ln 5. It's going to be gross. There's going to be a lot of 2 ln 3 plus 2 ln 5 plus 2 ln 5, close out parentheses, and then close the overall parentheses for the top, right? And then divided by, and put parentheses again, it's going to be ln 5 minus 3. ln 5 minus ln 3, yeah. Okay, so ln 5, close out parentheses, minus ln 3, close that parentheses, and close the whole bottom parentheses, right? Let's hit equal here, and we get 10.06, 10.603, 10.603. Okay, and that is it. Good job. If you have any questions, please bring them to class. We can talk about them. I know that last one has a lot of algebra in it, but hopefully you guys are really good at algebra at this point. We're wrapping up our year. Hopefully you guys are masters at algebra. The sad part is that as you guys go into calculus, those of you who are doing calculus eventually, the concepts in calculus, while they're kind of big and they're kind of big brain concepts in that way, people eventually understand the concept. It's just that they get hung up on algebra, right? So for those of you who are planning to take calculus, please brush up on your algebra skills, especially the more advanced stuff. Yeah, if you can, find any practice problems you have and work on those, and figure those things out, because I guarantee you it'll help you out in the long run. All right, good job today.